In this scenario, we have Nisha on her sled at the top of a hill. So we draw the hill like this. And here's our friend Nisha on the top of the hill on her sled, like so. And she reaches the bottom of the hill, so we know she makes it to the bottom. And this, of course, is the beginning. She's up here, and then at her final position at the bottom, final time. And so there is a initial position and a final position. And the other quantity we would care about would be the velocity. Now, there's an initial velocity at the top and a final velocity at the end. Now, in terms of the time, what we might care about is the change in time or the time interval. And what we might care about in terms of position is the change in position. And for the velocity, we might care about the average velocity and the change in velocity. So those are all the things we could possibly need to know about this. Now, when it comes to any problem, the approach, when we don't know how to solve it, is to do everything. If we do everything, we are going to figure out that one thing that we need to know. Oftentimes, it's easier to figure out everything and helps us understand better than if we try to just find the answer. So we know she's on her sled at the top of the hill. She reaches the bottom going at 7.0 meters per second. Oh, so her velocity at the bottom is 7.0. And we know it took 4 seconds. Well, that 4 seconds is the total time it took. Now, if we look at the other times, we're not given any other information about time. So we might say, well, maybe in the beginning the time was 0. Well, if the whole time she was traveling was 4 seconds, then that means the time at the end was 4 seconds. Now, notice we don't have any information at all about positions. Well, let's then look at the velocities. We're not told anything about the average velocity or the change in velocity. And what about the velocity in the beginning? Well, if she's at the top of the hill on her sled, the best estimate we might make, or the best assumption we might make, is that her velocity was 0 at the start. She went from some speed 0 to 7 at the bottom. You start at the top, usually your velocity is 0. So even though the number 0 is not stated, that is the best, most reasonable value to apply to that. Now we're looking for the average acceleration. So our average acceleration formula is the change in velocity over the time interval. Well, if we look over here on our drawing, we don't know delta V. But the change in anything, like the velocity, is equal to the thing at the end minus the initial. And at the end, we knew it was 7.0, and it started out 0, so the change in velocity is also 7. That should stand to reason, that if we started at 0 and ended at 7, the change is 7. So we do, in fact, know the delta V. And we know the time interval, delta T. So now we can substitute in our values, and we get 7.0 all over 4.0. And that gives us 1.75. So 1.75 is our value, and our units, the units of acceleration, are always meters per second or meters per second squared. Now, the last thing is, how many digits do we report? The 7.0 has 2 digits, and the 4.0 has 2 digits. So that means our final answer should have 2 digits. And you can see that next digit, the 5, would cause the 7 to round up, which means that the average acceleration is 1.8 meters per second squared. And that is our final answer.